KCB Limited for a while. So they readily come up with they come up with their own titles based on our discussions, and in spite of in a very busy schedule, especially during the end of the year, they agreed to come up with giving us dates for this wonderful program. So today is the 6th edition. We have Engineer KP Harikumar sir. He's actually part of IEEE Kerala chapter. Engineer Harikumar sir is actually the treasurer of Kerala PES chapter currently, and he has been leading us for the last several years with the chapter activities. So very important subject today from the presentation from Harikumar sir here. In fact, power system SCADA is an important subject. For me, we had some, because Sarah has been with the SLDC, State Load Dispatch Center. I've been personally officially contacting him for the last several years for different kind of consulting. When we were installing the first IPP solar project, first independent power producer project, solar project in Kudalmandam 4 years back, we actually implemented a SCADA system based on our tender specifications. It was something like a SCADA with visibility and getting the visibility is at remote level. At the same time, we will be getting all the updates of the generation. We'll be getting the updates of weather data in terms of the solar insolation or kind of global inclined generation using a pyranometer there. We will be getting the online temperature data, wind data based on a anemometer there. So all these kind of things are streaming to our desktops. Though we had this kind of arrangements, SLDC instructed us to do kind of a new setup, which is we should comply with the SLDC requirements as instructed by KCB Limited. So we later changed based upon SLD's advice, and we added a RTU, a remote terminal unit, into it, a separate kind of hardware into it to make it a real-time SCADA for SLDC people to view it online and to make changes. It's a kind of SCADA. They can do a little bit of control as well. Anyway, very interesting subject. Sar is very experienced in that, so there is no introduction for Engineer Harikumar KP. Sir has been with SLDC for quite a long time. Currently, Sir is with the transmission subdivision Pala, working as an executive engineer. He has been with us with our activities, leading our activities for quite a long time. So thank you, sir, for making this event a wonderful thing with your presentation. Welcome from, though you are part of the chapter, I'm officially welcome you on behalf of the chapter. Thank you, sir. Thank you.
Thank you, Ajit Gobi, for your warm words. Thank you, Suez sir, IEEE PS Kerala Chair, for his welcome speech. Thank all the people present for this hearing my presentation today. So I will just actually I worked in the state load dispatch center for some time. That is mainly load dispatch operations. I worked for only 1 year, but mainly I was working in the communication wing, that kind of things I was working. So today in my presentation, I will give a brief overview on how a power system SCADA is implemented and how It helps the load dispatches for the economic operation of the power grid. So, shall I start the presentation? Hello, am I
Yes, sir.
audible?
Yes, sir. You can
Yeah.
start it. You can share
So
your
I'll
screen.
start the presentation. Can you see the screen, everybody?
Yes, sir. Can you make it as a
Yeah, I
slideshow?
will make it.
A
Okay.
slideshow.
So I will start the presentation. So the topic for today is economic and accurate load dispatch functions. So what is basically a SCADA system? It is a system for remote monitoring and control that operates with coded signals for communication channel. So you can see various types of SCADA. That is, SCADA is there, industrial automation SCADA is there. So the basic concept is all the same. We get data from our remote stations, remote industries, or whatever it is, and all the data you can see in a human machine interface, and you can use the data for the timely operation of your power system or whatever industry or process industry or whatever it is. So you can see the basic components of the SCADA system. You can see what it is. From the remote stations, using remote terminal units, you can get the various details like voltage, current, or other switching operations. This all transferred through a communication medium, and it reaches a in the case of an electrical utility, it is a load dispatch center. So whatever data it is coming from the remote end, you can store in a database server. There will be application servers are there, and it will be shown in a graphical user interface for the operator or whoever is controlling the system to take timely actions. So that is a basic, what you see on the screen is a basics of a SCADA system. So what is the need of SCADA system in a power system? That is, it is for managing the interconnected grid by real-time power flow, alarm, etc. So the operator can see on this screen visualizations on whatever is happening real time, how the power is, power flow is, how much is the generation, that kind of things. He can monitor and take timely action so that the grid can be managed effectively. That is, next is economical import and export of power. That is, export on and import of power. You can economically, because today the power system operations are very much dependent on this financial criteria is very big thing, because as you know, in the current scenario, we are Kerala is having only a 30% or that much kind of power is only we are generating, and remaining bulk of the power is transmitted from outside. So so operator has to take timely decisions whether we need to bring power from outside, at which time, how much megawatt, and depends upon, as you know, the our grid is managed by uh, in in a period of 15-minute period of 15-minute period we are managing it. So in that 15-minute period, we have to schedule how much power we have to bring how much power you have to buy, that kind of things, very timely. That has to be done within before 2-3 time blocks. So decisions has to be is very critical. And another important thing is that provide reliability of power. That is a quick response against outage of major line or generator. So sometimes if a major line or generator trips, so based on whatever we're getting from the field, the timely actions has to be taken. There is next is energy management system for planning, forecasting, because with the help of historical data. So load forecasting has to be planned in advance. So we have to need because if we are not forecasting properly, there will be shortage of power and shortage of power. This is a SCADA connectivity diagram of our KSCB, as well as it is also showing the southern region of southern region, that is Andhra, Telangana, Karnataka, Tamil Nadu, Pondicherry. It is showing the SCADA connectivity diagram. We are having remote terminal units in substations where we get the analog data as well as the status. It is normally transmitted using IEEE 101 protocol. It is taken to a DCPC, that is a data concentrated current protocol converter panel. And it is, we are having a main control center at Kalamasheri, and there is a backup control center at Trivandrum. Similarly, the other states are also having these main and backup control centers, and it is connected to our control center at Bangalore, SRDC, Southern Regional Load Dispatch Center, and it is also connected to control center in Delhi, NLDC. It is connected using an ICCP link, that is ICCP link. Okay, that I will go to in detail later. So what are the components for the main console SCADA system? That is a data collecting or receiving units in field, RTO gateway or DCU. There will be a communication subsystem. There's a background. The data is transmitted using this communication subsystem. DCPC is a communication front end SCADA network control center connected to SRDC, MCC, and backup. That is main control center and backup control center or wide area network. The data are mainly two types, that is analog as well as status. The analog data collection is mainly done through transducers, MFTs, and meters. MFT is multifunction transducers, same as transducers, some with additional functionality built in. The status data collection is done using auxiliary relays or using potential free contact. That is how the analog data collection is done. That is, it is mainly transducers. They are having inputs like inputs from the secondary of the current transformer, potential transformers, and they are powered using auxiliary supply. Some 48-volt DC is needed for the operation. And whatever input we are giving, that is a CT inputs like 1 ampere, PT voltage like 110 volt. We are giving giving the transducer. We will get output that is in the range of 4 to 20 milliampere, proportional to whatever megawatt voltage current, tap position and frequency. There is a megawatt of a particular line, megawatt voltage, current, tap position and frequency. Everything we can get from the transducer. This is an image showing a transducer. Is an active transducer. Here we are having IR. In the drawing, you can see there is a current input is 1 ampere. This transducer is using two-wire method. That is only R and B is there. It is having an auxiliary supply, 48-volt DC. Output is 4 to 20 milliampere. It is having PT input 110 volt, CT that is a secondary current that is 1 ampere, it is input. This is multifunction transistor, basically transistor only, but it is having output four numbers of output corresponding to whatever inputs you are giving. But the main advantage of multifunction transistor is that is having an output of we can get the output using RS-232 or RS-45 right-way communication, because in the case of transducers we are directly connecting output of the transducers directly connecting to the analog input cards of the RTU. But in the case of transducers, we can directly get communication output we can get. This is a meter. Meters you can get CT. It is having input CT and PT voltage. That is also communicating in Modbus protocol. This is how the status data we are data from the status we are getting, that is like breaker close. We need to get the status of whatever breaker it is open, close, isolator is open or close, and SOE, that is sequence of events. Because sometimes when a major fault occurs, something like that, the breaker trips, and sometimes we need the accurate information on how the fault occurred in the position, so that we can get the details to prevent further tripping like that. So that sequence of events, it is mainly time-stamped events using which time the breaker opened or closed. Sometimes it may reclose on if it is reclose and again may go into fault, that kind of thing. So that is sequence of events. This shows an relay used for getting the status. There is the 110 volt from the breaker isolator or trip circuit. Whenever breaker close this circuit, this 110 volt DC coil will be energized, and this corresponding 48 volt circuit to the analog this input card will make, and it will give us send a status indication change over the load dispatch center. That is how it is implemented in the field. That is whatever this is the are you hearing me? One second.
Yes, we can hear you, sir.
Yeah. 1 second.
Is the presentation struck there, or is?
Yeah, it is there, but that one thing is hiding my view. That's why I'm trying to move it.
Okay. Go ahead, sir. We could see your presentation.
Yeah. That. This is whatever you have seen. So this is how we are tripping the breaker from the RTU receives the. So I will just leave and come back 1 second.
Okay. Harikumar sir will be coming back. Sir, apologies for the small technical glitch there. Due to network issues, sir will be back soon. So kindly be patient for at least for some time. He's trying to reconnect. Karnil, sir.
Ajit ഒന്ന് ഫോൺ ചെയ്ത് ചോദിക്കാമോ?
Sir, actually, I have contacted him. ഞാൻ ചോദിച്ചായിരുന്നു.
ശരി ശരി.
Sir, he is trying to reconnect. Actually, there is some issue with his laptop. He is trying to reconnect through phone.
Okay, we can wait. No problem.
Sir, yeah. Meanwhile, some of our leaders can volunteer to enlighten us. The request. Some of us, I think Harikumar sir will be joining soon. Request some of our leaders to please switch on your video and speak to us, to the audience.
I request Mr. Suhair.
Sir?
I request Mr. Suhair to speak first. Is he hearing?
Professor Chandramohan is the right person to talk in this interval. He has many things to share, not only technical, but even he's a good singer also. He can also sing a song. And make the evening sweet.
Let him come back anyway.
By all means.
I only have appreciation to the team, especially led by Ajit Gobi, taken a lot of pains to
Thank you, sir.
materialize this. When we discussed it in the committee, what came to my mind was only 3 topics. The general perspective of the generation sources, then transmission systems and distribution. Now we have gone to many areas. A lot of insights to people, especially for our budding engineers.
Yeah,
We will
actually
discuss
very
anyway
learning, very good.
after the sessions are over. We will discuss anyway what are all the possible projects that could be.
When I scanned through the objectives of the Power and Energy Society, one word struck me was it is the largest forum sharing latest in technological developments in the electric power industry. So that is what struck me, what PES stands for. And today, our power utility, the Kerala State Electricity Board, has people touching all the new spheres of technology and trying to apply it in reality. That's the most important thing. We read many things in journals and books and for conferences and all that, but here they are trying to translate these ideas into action. That is really commendable. And we power engineers are really proud of these great accomplishments.
Hari is back.
Yeah. So Hari, take over, please.
Sir, sir, you can continue, sir.
Harimar sir, kindly.
Can I continue?
Yes, now.
Yeah, sure.
Go ahead, sir.
Sorry for the glitch.
Okay.
It's okay.
It's actually when I logged out and when
we don't expect interruptions from SCADA, you know.
Yeah, SCADA errors. Sometimes it will happen in our load dispatch center also.
SAR has actually a lot of automation systems, open source based automation on Raspberry and I think Arduino board and all. I think he's an expert. We expect another presentation from him shortly. Maybe we will schedule it separately. So actually,
I'm doing some home automation open source in my home that automatically switching on the lights and in this sunset. That kind of conditions are checking, and I can control from phone also.
Okay, sir. Great,
yeah,
sir.
I will continue.
Yeah. You can just brief it at the end of the session. You can just brief it up. Yeah. Thank you. Go ahead.
This time I will just give. Okay, thank you. I will continue. This is data receiving units in the field. So when someone from the remote control center give a command to open a breaker, what happens is it will energize the 48 volt DC circuit, and it closes the heavy duty relay contactor 110 kV tripping circuit that close or open breaker in the field. That is what happens when we give a command from the control center for normally for opening a circuit breaker. So it is having an HTA relays as input, 48 volt DC output. So that is I will just show the circuit for that. It is
sir,
like
your presentation is not there. You can just share the presentation.
Sorry. I didn't actually share the screen. So
yes, sir. Perfect. Go ahead.
Yeah. So it is how it happens when a command from the control center, it will close the 48 volt DC circuit in the status card, and when the 48 volt DC coil is energized, the corresponding output contact, that is a normally open contact, makes, and it will complete the trip circuit for close or opening of the circuit breaker like this. This heavy duty relay contact is because it is for, because of the current it is taking for the closing and opening operation of the CB trip coil. So this is the primary data acquisition unit of an RTU. It consists of its central processing unit, I/O peripherals, communication ports, and power supply module. So it receives the power request from the data concentrator, some protocol converter, or front-end processor through its output communication ports, and scans the data from its input peripherals and send back to DCPC of a power output communication port. So whatever changes, that is the RTU and the front-end processor, or whatever it is in the control center, it is communicating to the RTU, and data is sent over through the IEC 101 protocol, that is serial data communication. So the communication is like that. The analog data, it is polled for only 10 seconds, and status every minute. That is if a breaker opening or close, or isolator open or close, that much, that kind of information that you have to get immediately. So not immediately, this exception, secant event, that is in the case of breaker tripping and all, that is due to a fault or something like that, it has to be instantaneously communicated. So the analog data is polled every 10 seconds. The status, that is a breaker opening or that kind of thing, it will, that is manual operation, that kind of status change is occurring every 10 minutes. But in the case of a tripping due to fault, it has to be received immediately. So this is the input peripherals. The RTU we are using in mainly it is GU Harris, that is GU Harris RTUs in our substations. So it is having input 32 number analog card, that is 48 volt DC operated. It is having input 32 numbers, that is 32 current inputs. That is corresponding to megawatt, megawatt. 32 inputs we can give in one particular card. So this is the output, means whatever input we are giving, it is sent to the RTU, from the RTU to the master SCADA master station. So you can see the image of the analog input card. This is a status card. It is having input 64 numbers. Status means breaker status, like open, close, that kind of things. It is having input 64 numbers, and output similarly it is a 16 or 15-bit digital output, and it is sent from the RTU to the master station. This image showing an input card. It is also output peripherals, that is whatever command we are sending from the control center, that is a breaker open or that kind of command. It is having this much inputs. So from the remote station, when you are giving a breaker, it will give the tripping command. This image. So I'll just give an explanation of what is RTU CPU. The RTU is having a database, and it is built using GE proprietary software, and it is named as Config Pro. It can be installed in a separate PC, and the details of the analog status or control inputs, and this can be loaded to the RTU CPU through the RS-232 maintenance port. It is having this RTU is having a power supply module. It produces 12, 5 and 48 volt DC for internal and external circuitry. This is a image showing RTU CPU module. Here, this is a power supply module. Here it is showing this one is the Westag D20 MVAR RTU being of GE Harris. That is we are using in the old SCADA system. But recently we are having this Crompton grease make RTUs also in the system. So this is the model of an RTU in our control center. This is for simulation and that kind of things we are using. This is a test RTU in our control center for testing purposes. So how the now you can move on to the communication subsystem for sending data. We are having the old type of data communication system like PLC, power line carrier communication, that all will be knowing. The sending end, the sending end means in the from the substation, the RTO output is connected to FSK modem and then connected to power line via PLCC equipments. So similarly, at the receiving end also, this the data from the PLCC is taken out and is connected to FSK modem. It is FSK modem is frequency shift keying modem. That is output from digital output from RTU is converted to analog data, and that is connected to PLCC and at the receiving end it is taken back. I will just show you an image of that. This is how the interface for data transfer using PLCC link. I'm not going into the intricacies of this PLCC link that all will be knowing. There is from the RTU data is taken to modem using frequency shift keying. Also through PLCC channel, we are having speech channels also for speech. That is in KCB, we are having an PLCC link for speech as well as data. And through the PLCC, it is at the control center, it is again taken to the PLCC. This analog data, it is converted to digital data and taken for display. This is a image showing how the frequency shift keying works. This is a digital bit stream, digital data from the RTU. There is a high frequency carrier wave and low frequency carrier, and there is a FSK modulated wave. Because for PLC, we are having a particular frequency for transmit and receive. This is how we are taking, we are having communication link using power line carrier as well as optical fiber links also. The all data, all substation or all data from remote generating stations and all where we are not having fiber optic link, we are taking data using PLCC. And our main backbone from Trivandrum to Kalamassery as well as Kalamassery to northern side, we are using optical fiber, that is OPGW, optical pilot ground wire, as well as ADMS, or dielectric self-supporting type of fibers. This is how the both PLCC and analog data as well as optical fiber data, both we are shown. Here is a modem RTU, PLCC. Then we are also we are having earlier, now this radio it is not there. Earlier we are having radio link, microwave radio link for transmitting data, but that now it is not there. Now we are having this communication link as optical fiber. So whatever data from the RTU, it is taken to a secondary mux, that is this is a submux. It is multiplexed, and it is converted to there is a primary mux also, and that is data transmitted and like that. So we are having this is a SCADA network diagram, because here it is sorry. Here we are having Kalamasheri data concentrated, some protocol converted. Data from various substations it is coming. Here new substations, new RTUs are commissioned, that is shown in red line. That is Alva, Arur, Edea, Muatura, this Pala. There is this is the older RTUs. So as part of the SCADA upgradation, a lot of stations, new RTUs had come up, and this is showing how the data is transmitted using how it is. Now we are having MPLS link also, PLCC. RTU directly connected to the DCPC, that is in some stations where we are fiber optic. So this is showing the connectivity diagram, OFC main link, optical fiber connectivity also. This is in the shown in the color. So these are protocols we are using. IEC 6087051 101, and that is in short IEC 101 and IEC 104 protocol. This is older RTs used to communicate using IEC 101. Now the new one is using 104. That is packet-based, packet-oriented TCP/IP transmission. The same thing, how the RTUs are communicating, how the data is sent. So here, here in some older RTUs, it is having 101 protocol. So we will convert it to 104, and then we are sending it to the remote station. The two are going to the main control center. If we front-end processor and other are going to the backup control center through the 104 protocol. So this is a DCPC data concentrated current protocol converter. It contains two separate computers with other outputs and all. Terminal servers, GPS switches, and network switches. The operating system is Windows 7. Some it includes CFE reader, some softwares are there for updating the RTU database, that kind of thing. So this is a diagram showing how the data is transmitted from RTU to the control center. You're having RTU having a IEC 101 protocol. There is a terminal server. There is a LAN switch. This is all time synchronized also. So then data is sent to the control center. So from this, it is a Trivandrum having data concentrator, Kundra, Pallam, Markatra, Kanye Road, and Trivandrum is also handling second. This is a backup data concentrator. So main components of the SCADA network, it is shown. It comprises SCADA LAN, data acquisition LAN. It is a dispatcher training simulation VLAN, ICCP inter control central protocol LAN. That is communicating with multiple control centers. There is an internal demilitarized LAN, external demilitarized LAN. That is based on the security, firewall and all. It is internal and external like that. There is a storage area network and NAS LAN also. That I will this thing I will explain later. This is showing how the data acquisition LAN and all images. This is a ICPCP. This is a data acquisition VLAN. This is the front-end process. They're collecting the data and sending to the this particular LAN. Is it DTS LAN is for training, dispatcher training system. This is the details of the front-end processor. We are having two front-end processors, 1 and 2, communication front-end. It will collect the DCPC data, and it is which are directly coming from IEC 104 and converted to IST protocol. This is having softwares like Windows 7. So the communication front-end processor, it offloads the task of communication and pre-processing between RTUs on both 101 and 104 protocol and DCPC and SCADA EMS servers. It is having sufficient number of boards for communicating the RTUs IEC 101 protocol. There is a router for communicating with control. Router cum firewall for RTUs shall be provided between RTUs for communicate with control center and 104 protocol. This image showing the SCADA image EMS server. This is SCADA LAN. This is the identity servers. This is for dispatcher identification, login details and all. This is the system we are seeing in the control center. We are having a display from the data from this SCADA line A and B. That is one is for redundancy. In case one line fails, that is a local area network fails. It is a backup for the backup. So the SCADA line having application process 1 and 2. That we are having SCADA and EMS applications running on it, and other 4 number of workstations or operator and SCADA personals. There's a identity server 1 and 2 for password authentication. There's a map board for displaying frequency, block number, time and date of day, color, and other things, GPS for time synchronization. So this is the main application for the application processor functions. It calculate the MVA, megawatt and megawatt integrations, rate of change, average value calculations, maximum minimum value calculations, system load and interchange data for SCADA operations, unscheduled interchange charge, line and transformer calculations, quality codes, real-time data storage and playback and all. So we are having quality code is that sometimes due to communication problems and all, the data may be good, bad, suspect. That kind of indications we can get on the display. We are having some this unscheduled interchanges charges are programs running as per Central LCD Regulatory Commission regulations. So we'll go to the next slide. So there is a network shader processor for checking the network alertness. There is a sequence of events recording also, because when a tripping happens, tripping or a major system event disturbance occurs, that events has to be recorded. The supervisory control, that is you can control the breakers from on the control center. You can inhibit the control also, because sometimes we can give an indication like if you want to, if you are not accidentally closing or opening a breaker, so check before operations. That check before if you are tripping. That can be all done. Otherwise, a mal-operation may lead to system collapse. actually controlled capacitor reactor devices, but that kinds we are not doing it remotely. That it is basically done from the field itself. Changing transformers also we can do, but that also nowadays it is done locally only. Then load shed support displays, alarms and events, data exchange utilities, data import export data to from external system. This is showing the interchange summary display of SCADA in our SLEC. This is the current what we are. This is in this particular time block. This is the block number 69. Revision number is the revision of the scheduling done from the SRLC based on the requirements of the person. So in this particular slide, you can see that due whatever you are due during that particular time block for Kerala system is 2011 megawatt. But actually we are having drawing only 1896. So we are the demand is 251, but we are having a due of 2011 from the interstate feeders and all. This much megawatt we are entitled, but we are drawing only this much. So this is O bar U. This is a 1 minus 150. So remaining it is met from the generation from our system. Here we are having the frequency. This is a current block unscheduled interchange that can do. This is a rate for the current block for the power we are drawing like that. This is a image showing Kerala generation summary. So megawatt, Kutiyadi, total hydro, total is 549. We are in thermal generation BDPP, KDP that time, that is now BDPP generation is not there. Then also from other sources, that is independent power producers like Angulam, BSS, this Maniar, Kuthangal, this is our captive power plants. This is IPPS. There is a total this much generation we are getting. As you can see, Kayangulam is 0, BCS is also 0. This is a image showing the Kerala grid. So due to the image being not clear, I think just not that much clear, right? The southern zone grid. This is showing the northern zone, central zone. So this is the display from SCADA window showing the actually I told you that sequence event, the tripping events, that everything will tripping or normal operations or whatever abnormal tripping, everything will be, we will get in the SCADA display. We are having this terminal LCB. This time it's tied to tied. Again, I think that is open. Then other Partipara transformer. There's all the whatever happening in the grid based on the system parameters. We will get all the indications on the like capacitor bank open. We will get in the SCADA. So in the SCADA software, we are having an EMS function, that is an energy management system. We are having a state estimation system, real-time contingency analysis for optimum power flow, RTNET, RTNET, PVD, load forecasting. This is all built in the SCADA EMS functions. It is a there is a state estimator. It is a solution of RTNET. There is a weighted least square algorithm. So based on the system condition, there is a voltage angle. It can give a based on the analog measurements we are receiving on the SCADA. Estimation of the system we can get, but for the estimation to be accurate, that all the network parameters like breaker status, isolated status from the field, analog or analog measurements, everything has to be correct. And from the voltage and angle, it estimates the power flow and losses. That is a state estimator. So network modeling, we are using pi modeling. All resistance, capacitor, inductance calculated for normal frequency and temperature. So it will analyze a single phase equivalent circuit, except short circuit conditions. The power flow from generator always positive. That is how they are taken. Flow out of bus positive, flow into the bus is negative. These are conditions for network modeling. The interstate line as modeled as generator only depends upon the power flow. So real-time, there is a facility for real-time contingency analysis. If a system is working with some equipment, one or more equipment fail or our system behaves contingency. So what happened if two generators tripped at generating stations? It will give violations of that particular contingency. It will rank the contingency as per severity. So this is what showing the contingency details as alarm. There is also a load forecasting module built into the system. We are having we need weather history, load history, climate conditions, and nature days, regression method, and alternate forecast method. Similar day, need weather, load shape, and average base. So currently, we are forecasting, the load is forecast based on similar day. That is whatever, now if it is a Monday, we are taking whatever load pattern was there on Monday, last Monday. So based on that and on the climatic conditions and other, if it is a holiday and that kind of things, we will forecast the load. That is done by currently by assistant executives in the shift. So we are not using the software module for load forecasting. So next is identity server. That is identity server is used in the SCADA. That is we are having password security shall be provided for access system, in operating system, another application. We can assign the operational certain functions or features of function to specific users of model group. That is a dispatcher. They can have special permissions, admin, supervisor, engineer, based on the level of this thing. We can give permissions. So if an engineer or dispatcher, they can do only control operations like breaker opening and closing, that kind of things. Then there is an ability in the identity server for orphan, dormant, and ghost accounts automatically. If the person is not logging to the system for some time, it can be that orphan, dormant, and ghost accounts can be removed. There is also a dispatcher training simulator on the SCADA system. It is having a inbuilt power system model, hydro system model, wind generator, and solar model also there. In this VLAN 2 dispatcher training simulator, The complete grid is mathematically modeled and used to study with simulation on dispatches. It is having the operating system Linux software, Etera habitat of G. Okay. This is a ICCP and storage area network LAN. ICCC servers are used for communication with inter control centers, other control centers. Storage is for storing the data and all. It is ICC server 1 and 2 support interstate data exchange between control centers. Storage area management server for taking the image of all servers. There is a network storage. This box for saving the images, optical tape drive. This is for, as I already said, online storage and online data backup. There is a tape library service archiving data available on storage area network. So this is what you have already seen for the schedule versus actual of our southern region. Just like what you've seen for the Kerala grid. This Goa is having entitlement 93. So they are scheduled entitlement of a particular current time block. They are having entitlement only 93. Schedule is they are scheduled 92. Actually, they are drawing only 90. There is a deviation of 2 like that. This Kerala is having an entitlement of 1067 megawatt for this particular time block. Schedule is 1927, actual this much. So there is a deviation, that kind of thing. So, also, this is a entitlement for that particular time block. Schedule they are 701. They are drawing only 7. There is some. This is the what you have already told, that the interior demilitarized line of the SCADA network. There is a data development server. This is for development of new SCADA databases and all. There is an NMS server, CMC server also. NMS server in that monitors all servers and workstations. There is an ISR server for information storage and retrieval. DDS server, that is a data development station, all workstations and all. There is a network management server for security management, protect systems and network from unauthorized access. Inventory management to collect information on computers, performance management and fault management and all. This is showing the system, various alerts and all of the systems. There is a information storage and retrieval ISR functions. We are having real-time database snapshot, playback, processing, reports. We can get daily reports, system message, log storage and retrieval analysis, historical trend. There is demand versus time graph. Everything we can get from ISR. Just an image showing the demand versus time graph. There is a centralized management console. That is for threat management, for integrated monitoring of this firewall and all. There is an intrusion detection and prevention system model. There is a network-based intrusion prevention system also in the CMC function. This is next is DDS server that is used for develop and maintain the SCADA maintain the SCADA EMS software displays and database for adding new network, RTU into SCADA network, for adding new feeder in a substation and all. Before this onlining the SL database, SLEs can be viewed in DDS data development server through the workstations. There is a image showing the data and external limiters line. There's a replica server, web server, patch management servers, and also the. It is responsible for updates and patches for software products applied. What patches have been applied and all that. This is an image showing the communication front end at SLDC Kalmasheri. Thank you. With that, I come to the end of the section. Okay.
Thank you so much, sir. Sir, we have received a request. Is it possible for you to share the PPTs later for the participants for the later?
Yeah, that I will share, no problem.
All right, sir. Sir, can we move on to the Q&A session?
Sorry?
Can we move on to our Q&A session? Question and answer.
Sure, no problem.
Sir, one question that we have got is that are we still using relays? Is there any advanced digital systems available to replace relays?
What relays you are talking about? What is an analog that status indication you are telling about?
We actually received the question like this, like are we still using the relays? Are any advanced systems available to replace those? If the question is not clear, we can move on to the next question,
Yeah,
sir.
actually, currently, what I had shown the slide that we are using for the status indications and all. There are, for other control operations and all, we are having advanced digital microprocessor-based relays in our substations for monitoring the protection. That is, if a fault occurs on the power system or whatever it is, that today we are having microprocessor-based control relays are there. But this thing, what I have told in that particular, it is just for remote operations. That is for the control center when you are giving a hand. The output switching has that trip circuit has to be completed for the breaker for trip circuit has to be completed. For that, this digital relays that is used. So that I think we can't change. That is a current norm.
Okay, sir. The next question, whether all substations in Kerala are connected to SCADA?
Not all substations. The major substations are connected. That I think I already shown in the PowerPoint presentation. One second. Major grid stations and other major 220 kV substations that are all connected, but not all substations are not connected because the data from this is a substation. The image I already shown. I think you have seen it.
Okay, sir. So the next question, what all are the parameters available at a substation level?
On the substation level, we can get the analog input. That is, analog means that voltage, current, frequency, that kind of. That is megawatt, MVAR, everything. Normally, in all SCADA system, that is, we are having all transducers. We are using only megawatt and MVAR transducers, and frequency. The megawatt. From whatever megawatt or megawatt we are taking the voltage, current that can do things. We are giving calculations in the master station for displaying the SCADA. But normally, but in our new systems and all, using multifunctional transducers, we can get voltage, current, that individual. These all things we can get. But in the old one, we are getting only megawatt, MVAR. frequency, that kind of things.
Sir, the next question. Can the system be expanded without re-engineering to handle future requirements?
Okay, that can be done, because that we are doing frequently, because sometimes sometimes in a new substation or a new feeder or something comes up, that thing whatever this one second. Whatever input from the field, that is that I already shown. This analog card is we can give inputs like 32 numbers. So so adding additional analog cards, we can give the details of the new feeder, like megawatt, or that kind of things we can add, and corresponding RTU database has to be added, and the same thing has to be done in the remote control center for that new single line diagram has to be prepared, and corresponding SCADA points assigned to that single line diagram. So that we are having a separate SCADA subdivision for that, where they are doing all this onlining. That is, we are having the database we are mainly using is SQL Server. So corresponding points we are adding to the database server, and from that it is mapped to the digital display. Okay.
Yes, sir. I think we have covered all the questions.
Okay.
We hope we can move on. So
Yeah,
I'm
yeah.
inviting Dr. Bobby Phillip, Secretary IEEE Kerala chapter, for the vote of thanks.
Okay.
Is Bobby sir here?
I think Bobby sir is expected soon.
Yeah, he's here.
He will be
But
joining.
he's not the host. Madhu, can you please make him the co-host?
Yeah.
Hello, Madhu, can you hear me?
Yes, Shweta.
Can you please make Bobby Phillip sir a co-host?
Yeah, sure.
Thank you. Bobby sir, the mic is all
Sorry
yours.
for the delay. Thank you, Shweta. Good evening, all. Respected Chair Suir sir, PS leaders Chandraman sir, Vijaya madam, Kasim sir, and all Execom members, participants, and dear students. As once Chandraman sir remarked during the course of this webinar, this has been in fact a feast for and electrical engineers in particular. So the topics covered a wide spectrum of the KCB operations, right from the status of the grid and the changes that are taking place as per the theme of the webinar. What could be the changes that can be expected in the future, or what are the changes right now itself it is happening? All those topics were beautifully arranged, just like colors in the Vibgyor. So it was actually the effort by our coordinator, Ajgobi sir, who is the vice chair of this IEEE Kerala chapter, who has very beautifully arranged it. I take this occasion to thank the experts. Today's expert, Harikumar sir, who happens to be one of the officials. He is actually the treasurer of PS Kerala chapter. I thank him for this wonderful session he had on we had on the SCADA and its operations and its various components, etc. It was an enriching experience listening to your talk. Thank you, sir. I would like to thank all others, right from Biju sir. Biju sir, I think he is also participating in this webinar right now. And Pradeep sir, Laiju sir, and Madhulal sir, and Harikumar sir, all experts who came, who actually in short notice, they agreed to present the topics in this webinar, and they took a lot of efforts, and their efforts were seen in those presentations, and the audience had a very nice experience going through various trends and the intricacies of the power system, the problems, and we could get a general idea as a layman also. We could, if you were attending, one were attending, he could get a lot of information regarding the operation of Kerala grid. It was a nice experience from the KCB engineers. So I thank all of them, one and all, who participated or who came over and took pains to present the topics during the webinar. And next, I would like to thank the organizing committee comprising of our Suesa, who is leading the team, and all other PS leaders. In fact, this idea was mooted in last EXICOM. In fact, it was referred in many of the EXICOM meetings, but in the last meeting, there was an effort and a decision to make it happen, especially as per the recommendation of VKD sir and Chandraman sir. And again, Ajit Gopi sir took the effort. I thank one and all on account of formality. I thank all the PS leaders for organizing this wonderful webinar series. And the participants, without whom this event is meaningless. In fact, well, from the very first webinar, several people were attending it regularly, and many have actually participated in all the webinars. That shows the kind of takeaway. I mean, they could actually get something. That's why they were coming. Coming for webinar after webinar, they were revisiting, and then that's an indication of the quality of the webinar series. I thank the participants also for cooperating with us, even in the presence of some of the technical difficulties we had. Some audio problems were there, some video problems. Even in the presence of that also, many cooperated patiently, waiting for the connection to come over and all. So I thank all of them for their patient listening. And last but not least, the volunteers, the student volunteers who has nicely helped us make this happen in a very befitting manner. So they cooperated with us in organizing this event, making all the facilities available to the presenters, helping the participants, and managing the question and answer session. I thank one and all who participated and cooperated in one way or the other with this program. With that, I conclude my speech. Over to Ajit Gopi sir for remarks. Sir.
Thank you, Gopi sir. Thank you, all the leaders. It was a great experience of conducting this program with a webinar series, and that too from the public utility we have been receiving excellent support, I should say excellent support from our one and only public utility, KCB Limited. The eminent speakers we had for the last 6 days, from 21st to 30th, from today up to today. We had wonderful experience. We have been listening to you on your ideas and on your experiences, on your projects. So wonderful experience. This was possible only because of the great participation from the attendees who are tuning to all the sessions for all the editions right from the beginning to the end, as Bobby sir was pointing out. And it was possible with the help of all the leaders, right from our chair, Suhair sir, Vice Chair, Shobha Madam, Secretary Bobby sir, and Treasurer Harikumar sir, and all the leaders like Chandramohan sir, Harindra sir, Bijuna ma'am, Nafisa teacher, Biju sir, and all the leaders. So I'm not naming all of you because you are calling me and supporting me for conducting it. In fact, I could, because I've been in association with, I've been working with KCB for several projects. So I used that opportunity to speak with them directly and get their appointments, because they were with their very busy schedules. So they agreed in between. We got top leaders. We got 2 chief engineers on board. And we got executive engineers and very top, vibrant executive engineers and engineers from KCB. So we are honored, actually. IEEE PS chapter is honored to we will take the strengths to conduct further very high technical programs in the further days. Just a word for Harikumar sir also. It was a excellent presentation from him. See, we expect more presentation from him on automation, home automations. Sir, we expect you to deliver on a talk on home automations on Arduino and Raspberry using kits and all. So it was a great experience from all the speakers. So another a small note to you, all of you. Just before concluding, I must thank the student community and young IEEE PS young professionals. So student team has done an excellent work, as Bobby sir has been pointing out. I'm not mentioning the names, but I have to mention some names from our student coordinator Anantu, Nitin, our Mathu Krishnan, Shweta, and some more participants volunteered for our activities. Nanda Kishore, then I think, yeah, a lot of people. Rohit has been making posters for us. So I would like to, excuse me if I'm not mentioning the names, but to you all guys were excellent. I should say that excellent support for me. In between, I was I was also held up with a lot of projects and a lot of assignments at office. But in between, you guys were amazingly supporting me, and of course the young professionals as well, updating the posters, updating the information, updating the links to the WhatsApp groups. So I also take this opportunity to offer my apologies for any kind of mistakes or kind of errors came during the presentation, or kind of miscommunication happened. But I hope you will take this as a spirit, in the spirit of our high-end presentations. So thank you all again. A short message for you. We are actually gearing up for another great series, a webinar series shortly coming up in the end of the second part of December. It will be an International Renewable Energy Summit. We are actually working on it. we'll be announcing it. I'm not sure about the total schedule at the moment, but at the moment I could say that we have some confirmed speakers from that end globally. So gearing up with all the support from you guys, from all the leaders. Of course, we need support for conducting that as well. What else? It's all with your support we could do it, and thanks for all the kind words offered to me, and all the support offered to me for conducting this and coordinating this. Thank you again. Thank you, and see you in the coming days, probably in the second week of December. We will all again meet together to have a wonderful session from the global leaders on renewable energy. Thank you again. Bye.
Can I add a word?
Yes, sir. Please, sir. Go ahead.
In appreciation of this great effort.
Thank you,
Special
sir.
thanks to Ajit Gobi Philip, and all teams, including our student volunteers. A great work done. In appreciation, as a mark of appreciation, I would request all participants to unmute your mic and
Thank you, Chandramohan sir.
Yes,
Thank you, sir, for your kind words.
Thank you,
Kumar,
Yeah, thank you, sir.
you did
Thank
well.
you.
I just remember
Yeah.
the meeting that we had at Tokach.
Yeah, I remember, sir. When you were the PS secretary, I took one class at Araguna. I still remember, sir, that talk.
Yeah, so
Yeah,
started.
thank you for your giving opportunity at that time.
You are a good volunteer of IEEE, and especially for
But
society.
I
And
think
I would like
since
to tell you that please get some members from KCB to IEEE. Yeah, try to get some friends joining IEEE.
Yeah. Thank you for your kind words, sir. Thank you for Suhail sir, Chandramohan sir, Ajit Gobi sir, Kasim sir, and Vijana ma'am, Bobby Philip, Sunita ma'am, and all. I think some people are not there, but even then, I thank for all for the support given to me in giving the presentation. And thank you, Ajit Gobi sir, for your kind words and all.
Thank you, sir.
all.
Thank you.
Yeah, thanks to Ajit Gobi for organizing such a wonderful event.
Thank you, sir. Thank you
Well
very
done,
much.
well done. Yeah, and I would like to
your
that
support.
if we can have a photo shoot.
Yeah, we can. We can. Kindly, as Chandramohan sir was asking, can we have a photo shoot? So
Yeah.
we will just kindly switch on your videos. We will take a.
Also, yeah, Madhu.
Yes,
Can
sir.
we have?
Yes, sir.
Yeah, please.
Madhu can coordinate to take a snap of all the leaders and all the participants. Student community also, please switch on
Camera. Yeah.
your camera.
One more thing, actually, I thank all the student volunteers who are behind the program for making the event a grand success, because without the involvement for making an event of this scale, a lot of background activity has to be done for the student people, and they have done it very well. Thank you.
Yeah, that's amazing, sir. Actually, it triggered. I should say that it's. See, I've been knowing all this student community, but it is something like amazing help. No, it is just like a network. See, even they arranged a one-man army to coordinate at KCB CE's office.
Yeah.
To make the session going comfortably on the host side. So that was amazing. No, just like a Kutti Patalam. So thank you all. So can we take a snap?
Yeah, sure.
Couldn't see Nafisa teacher. So Mathu.
Harikumar, please adjust your camera. Today's speaker.
Yeah. Okay.
Yeah.
Fine.
Yeah, thank you.
Laptop, you can slightly adjust so that your
Biju sir, can you, Biju sir from KCB. Biju sir, can you come up with your video? Is it possible? Though it was a surprising announcement of unmuting your video, I think it will be quite surprising at some time.
Lega, I think Lega, you are at your office or home? That is, you are wearing the mask and seeing with mask.
Okay. Madhu? Madhu, can
Yes,
you?
sir.
Yeah.
Can we have?
Yeah, you can have this.
So, yes, sir. So on a count of 3, can we have?
Yeah.
Yes.
Yeah, good.
So 3, 2, 1.
IEEE.
Okay.
Okay.
Yes, sir.
Thank you.
Thank you. Thank you.
Need one more.
Thank you, sir.
Take one more.
Yes, sir. So again, 3, 2, 1.
IEEE.
Done, sir.
Okay, thank you.
Thank you. Thank you very much.
Thank you all.
Bye. Good night.
Thank you.
Good night.
Thank
Sir.
you.
Thank you.
Thank you. Thank you. Bye.
Okay.
Bye-bye.
Thank you. Bye.
Thank you, Suhail sir. Very
Actually, my
Thank you. Ajit Gopi.
colleague
Thank you.
Lega
Thank
is
you.
also
Thank you,
joined.
ma'am.
Thank you for joining, Lega.
Thank you, Hariumar sir.
And
Thank you.
special
Thank you.
congratulations to Suhair sir for bagging
Yeah.
prestigious
Yeah.
Council Outstanding Volunteer Award.
So great.
Yeah, appreciation to Suhair sir. So thank you all.
Thank you all. Bye-bye.
Thank you.
Bye.
Thank you. Thank you.
Thank you. Thank you. Bye.